All right, so we're on, ready to go? Okay. All right, so what I'm going to talk with you about today is not the certification issues that are prominent today regarding if we can make hydroponic systems be organic certified. They are right now under regulations and under the current certification rules. They are able to be certified organic, but that's kind of a whole other discussion, which we've had another day. So today what I'm going to talk to you about is some of the challenges that we've had on actually using organic nutrition in typical hydroponic systems. So there are a few different products and a few different systems that I've been experimenting with. But my guiding question was, is it possible to use a liquid organic nutrient solution in place of a traditional inorganic nutrient solution? So a lot of times with organic systems, you're going to put some other nutrition in the media, but I was not looking at that. I want to find out if we can create or use a nutrition that is all liquid in the drip line, just like we would use an inorganic mineral-based formula. So what I started off was with looking at tomato production. So it would be using a typical coconut core media with a top drip system where you're going to feed that nutrition with the top drip. So why might this be a challenge? Well, when you use liquid organic nutrition, it has a high amount of decomposable organic substances in it. So things are still decomposing. There's a lot of biological activity, a lot of microbiology that's in play, and they're still decomposing that organic material. And when they do that, they're using a lot of oxygen. So we could have deficits of oxygen in these systems. Is there enough nutrition available at every point in time that that plant needs it? Another issue, because of the microbiological activity, you can get biofilms that form. It can plug up the drip systems that we typically use. And another issue that we found is pH fluctuations. The microbes in these systems tend to like to keep a pH that's a little higher than we're used to. And the pH will fluctuate quite a bit more than in an inorganic chemistry-based system. So, that may affect your nutrient availability in the long run. So, two main sources of liquid organic nutrients were used in my studies. The first one was using Compost Teas, and I'll explain that in a second. And the other one was using a few different commercially available liquid organic fertilizers that are on the market today. So the first thing I did was I wanted to try to create a compost tea, which is basically, I think I have that on the next slide actually, but compost teas are typically used for field production or raised bed production in order to create a larger number of microbes, beneficial microbes, and a larger diversity of those microbes to help cycle nutrients and get more nutrients in the soil to be available to your plants. And usually it's a very small amount of compost used compared to the water. So it's about 1 cup of compost per 5 gallons of water. So what you do to make a compost tea is you take some good compost. That all starts with a good compost. Compost is very variable, but as long as you have a good compost, you're going to put some compost in a mesh bag. You're going to add some different things, but typically use molasses as a food for the bacteria to grow, kelp, and rock phosphate. And so you add some of those, and most of the time you can make it as a non-aerated tea, which the research has shown has actually some pathogen suppression ability, more so than an aerated tea. But most of the time you're going to aerate that tea to really bring those good aerobic, beneficial bacteria, fungi, and protozoa into play for you. And then, so you you will aerate that with just like a aquarium aerator for about 24 to 36 hours. Then you can take your bag of compost out and you can use that tea that you've created. So we're not actually making hot tea. It's actually a cool process in a greenhouse setting. We're just aerating it. And we just call that a brew. So what I did was, when you use these on the field, again, it's for microbial benefit. But in a hydroponic situation, we need nutrients. So I had to add quite a bit more compost in order to get added nutritional value to that tea to then feed my plants. So what I found out was it took a lot of compost to get nutrient levels to where I could actually grow a crop. So I was growing cherry tomatoes, and I ended up having to use about 16 cups of compost for that 5-gallon bucket instead of just 1 cup with the typical system. I was able to grow tomatoes successfully. They were not as leafy. They didn't have nutrient deficiencies, but they just weren't as leafy, and the fruits were a little smaller, but I was able to grow them. I did find that the pH was quite a bit higher, more in the 8 to almost 8.5 range. And at first I tried to decrease that pH using citric acid because, again, I want to do this in an organic method, and you can't use nitric acid or sulfuric acid for organic systems. So you have to use not as strong as of an acid, citric acid, to bring that pH down. Now the problem with that is it did not keep the pH down. As soon as I brought the pH down to 6.5-ish, a couple hours later, it was back up to 8.5. It was just a losing proposition of having to add so much citric acid to control the pH. So eventually I said, you know what, let's just see what happens if I don't control the pH. Let the microbes do what they're going to do. And it worked out just fine. So my hypothesis is that I think the microbes, even though the bulk nutrient solution had a higher pH, I think those microbes at that root level, at the rhizosphere, they're changing the pH enough that they're able to uptake the nutrients that are needed. Okay, so that was with compost teas, and I quickly determined I just think it's going to take too much compost, too often have to brew it to actually be able to use this on a even semi-commercial scale. So I kind of gave that up. So I wanted to try out a couple of different products. There's one product on the market from a company called Chematech. It's kind of expensive. It comes from Spain, and the main source of nitrogen is sugar beet molasses. But I grew with that, and it worked pretty well. Again, the pH was difficult to control, and so I kind of let the pH just fluctuate and stay kind of high, and it still worked very well. These plants were much more vegetative than my compost tea plants, but I did get tomatoes off of them as well. So that was just a really short experiment. Now, the biggest experiment that I worked on was with a company that was using produce and plant waste material and decomposing that in a commercial scale system and making liquid organic fertilizer out of it. So it's a very sustainable approach, except for the energy intensiveness to, produce that from the waste, but you're using a waste stream. And this company had been using it in the field very successfully, but they wanted to see if we could use it in a hydroponic situation. So we took that liquid organic nutrient, and it was not a complete fertilizer on its own for hydroponics, so we had to add a few inorganic minerals that are organic approved to make it a complete hydroponic solution. And so we tried it out on tomatoes, a similar system. This particular product had a very low pH, about 4.7 and 4.8. Even when you add your tap water, that's about a 7.8 in pH. So we just can't deal with that. So we added some calcium carbonate to the media. That's the only thing we added to the media to bring that pH up to 6.5, between 6.5 and 7. And that's what that liquid nutrient looked like. It almost looked like a milkshake. So it's kind of thick, but not too thick to go through the system. So on our first trial, we did not have any problems with the emitters plugging, but we did have problems where the top of the media got all gunky. So the material got through the drippers, but something happened after that where it either came through the drippers or it formed later. But we got, I'm sorry the lighting's not good here, but it made this brownish gunky material on the media, and then it formed gunk on top of the block with some algae, and it just prevented the flow of nutrient to go in there very well. And in with that, so with that slime layer, what we found was the roots were not penetrating because it was low in oxygen there. So the roots started going lateral and started trying to pop out instead of deep in. But we were able to grow the plants for a few months without this becoming a nutritional issue. But overall, before all that plugging became too difficult, we did find that the growth of the inorganic plants was less or not as good growth as with the inorganic fertilizers. So whether it was a nutrition thing or this problem with the oxygen or the problem with the gunk, something was not allowing the nutrition to get to the plants optimally. So we decided, well, let's see if we can microfilter this nutrient. Maybe there was something that was just too large to go through the drippers or dissolve enough. So we got a microfiltered batch of the liquid fertilizer. Here's the interesting thing. It was microfiltered, but within 24 hours, the drippers plugged. What is going on now? And we were still getting, if the nutrient was getting through, it was forming all that gunk on the media. And you can see that brown gunk was plugging the drippers at this point now, even with the filtered solution. And we tried to isolate all the different variables. Was it the inorganics we were adding to it? Was it the tap water? We had no other factor. It was something in the fertilizer itself, in the liquid fertilizer we were given by the company. And when the company analyzed the gunk, it was mostly made of yeast. And that was a product of one of the components they added to their fertilizer. What's that? Oh, it doesn't matter. So one thing we tried to do is even filter it more to try to get the gunk to filter out. So we put a filter in line with the drip line, and it still created plugging. It didn't filter anything out. And another interesting thing is I tried another liquid organic product that didn't add yeast to their product, but they still had some gunking when I was using their product, not as much as this product. So there's something else going on. The original company ended up not continuing with us, so we didn't get any further to figure out and solve the problem. But there you have it. There's some issues that we're getting with these really nice sustainable products, but they're difficult to use. So I thought, okay, if we can't use that particular product in a drip line because it's going to plug up, can we use it in a liquid culture system? Then we don't have to worry about drip systems plugging. So with the advanced crop production course, we did a little experiment last year, and we did one deep water culture system with 4 different treatments. So we had a control that was just our inorganic solution for lettuce growing. Now the 2 that are diagonal, organic 1 and organic 2, are the one main nutrient solution that plugged up, the one I was talking about. And then the third one was that second organic solution I tried, that had a little bit of brown stuff, but not as much. So that was organic 3. So we put those in there. We matched the nutrient profile from the inorganic to what those organics would be, again, using the organic approved minerals. And in this case, we're not using an injector system. We have to mix this into our water tanks. Now, because this material has so much decomposable organic material, it's still undergoing a lot of nitrification. And in order to actually have the nutrients available to the plants right away, you have to aerate this stuff for a few days and get the nitrification to kind of settle down. So what we did was we mixed up the nutrients and we aerated them for 3 days before we put the plants in. And when you aerate it, it bubbles up like crazy. I think I've got a picture up here. Yeah. So you get all this bubbling for the first few days. And the bubbling really indicates all this nitrification is happening. And then your pH stabilizes. So the pH, remember, started at about 4.8. Well, once your nitrification starts happening, your pH rises, and you're going to get back up to your 6.5 to 7 that you want. And then after a while, you get a little higher. But at least after a few days, your pH is where you need it, and you put your plants in. So after 3 days, it was still bubbling, but I figured it would settle down. We put the plants in. We put them in a little too early, but we stuck the plants in there. So here's what happened 11 days after we planted our seedlings in the system. Our inorganic control looks great. The 2 with the same nutrient solution, they were just 2 different concentrations. One was a half strength, one was a quarter strength. Not doing good. But that other product was doing, they were kind of behind the inorganic, but they were growing. After 4 weeks, our inorganics, of course, look great. That solution I've been using, everything's dead. Nothing grew. The other solution, though, they look pretty good. They're just a little behind. So here's what it looked like under the boards for that organic solution, the main one. Dead roots, slime. Okay? We were aerating everything. Nothing went anaerobic. Okay, so one of my questions was now, well, did we put the plants in too soon? Did we not aerate long enough before we put those plants in? So we made some new, we took the dead plants out, we put in new seedlings, because now it had been 4 weeks of aeration. All right, the nutrient levels might be lower, but we had aeration for 4 weeks now, so we should be good to go. So we put those new seedlings in, and in a couple of days the roots died, dead. So five days later. So we put the seedlings in, and that's what we got. But when we put the new seedlings in the inorganic, of course, they're growing wonderfully. And then we put it in the other brand of liquid organic nutrient, and they were growing great. And they grew at about the same rate at this point. Because remember how before that other one was a little slower than the other one. So an interesting find with that other liquid organic nutrient was that it aerated, it bubbled for less days than the other one. So it kind of equilibrated a little quicker. And what we did in our first trial, the reason that those plants were a little slower to grow than the inorganic control was we aerated for the 3 days, and then we planted, but it continued to bubble for 2 more days when we put those plants in. Well, basically in those 2 days, those roots started getting brown. But then as soon as the 2 days were up, they started recovering. So look at these pictures. Okay, so after 3 days, so this is, the bubbling didn't completely stop yet, but I stuck them in there. the roots started to get brown. But after 11 days, so 2 days after that picture, the bubbling stopped. I'm still aerating, but it's not foaming up. Look at the nice white roots that started coming out. So the plant started to recover. So there's something that needs to happen with the aeration and getting those microbes and getting the decomposition to occur to a steady level before you put those plants in. And then look at this. 19 days later, whew, crazy good white healthy root growth. And then look at this. And at 28 days, wonderful root development. And we had nice full head of lettuce heads. So that nutrient solution has a lot of promise, and that's one I want to continue working with. So my next step is to do two things. So the first thing is I want to take that nutrient that I just talked about, that other organic nutrient, and I want to see if we can grow tomatoes using an undercurrent system. So basically an undercurrent system is like a big NFT that you can do bigger plants with. So you have a sump tank, and see in this case we don't have a drip system, so I don't have to worry about plugging drippers up. But if we can keep it in solution just like we did in that big raft system, maybe we can grow tomatoes this way. So we have big net pots that go on the top of the system, and we just recirculate and we provide aeration in every single tank. So I have some interns this semester, and they're going to help me to build these systems and try this out with that organic solution. Then the other thing I'm going to try out, and I'm going to have my intern students help me, is there's an NFT system in the student club greenhouse that the club has generously allowed us to use. And we're going to split that NFT system into two different systems. And we're going to use a product called Terra Bella. This is another liquid organic, commercially produced fertilizer. And we're going to also use Terra Bella, which is a microbial inoculant. So it's just a bunch of beneficial microbes that will kind of jumpstart the system. And so the research, the anecdotal research that's out there says use these two products together for the best results. So I'm very interested to see, number one, if we can grow good stuff with Terra Bella, which anecdotally, again, I've heard good things about, and that it grows green crops very well, but it is very expensive. That's another thing. But I want to see how important it is to add the extra microbes, because all of these organic liquid products have some dormant microbes in them. And when you start to aerate them and put them in your system, then they blossom and they do what they need to do. But when you jumpstart it with the microbes, you either will get growth faster, or maybe you won't even get the growth without it. I don't know. So we're going to split the system and do one with the inoculant and one without. And we're going to try basil and lettuce and see what we get. So those are kind of our two next steps to checking that out. And that's, I believe, all I got. So now we can open it up for questions. Do we want to, okay. Austin's going to bring around the microphone for you.
Stacy. Stacy, I know you haven't had an oxygen meter, but it would be really interesting to, as you aerate, we found that even though you aerate profusely, and you know this, that you haven't been able to get the oxygen over 0.5 parts per million dissolved oxygen. So,
right.
Yeah, very
yeah.
good. I enjoyed it.
Yeah, it is difficult to keep those oxygen levels up a lot of times. So it might require more extensive pre-treatment of a lot of these liquid fertilizers before we can actually use them in a growing situation.
Stacy, I found your presentation really, really interesting, but creating lots and lots of questions.
Of course.
So I'm going to make a very simple analogy. Last time I baked bread, I had a lot of bubbles in my dough. And that comes from microorganisms, specifically yeast, that take up oxygen and release CO2.
Right.
So and then, of course, when you say that the bubbles disappeared, it sounded to me like a large proportion of the microorganisms probably died. And what they released are the minerals contained in the cells of the microorganisms, which now brings us back to a kind of modified Hoagland solution, which is inorganic in nature. Do you think that's a reasonable explanation?
Yeah, no, I agree with that. You are killing off, I think some of the microbes are dying off, but there are certainly still some in there, and that decomposition process continues, especially when you start putting that nutrient solution in your growing system, because they're going to start to decompose dead roots in your system and still feed off the nutrition. So you're still going to have I think, a pretty good level of microbe activity, even though it might be less at that jump start. But again, we're jump starting it with and infusing with a large number of microbes to really make stuff available, make nutrients available. So when it subsides, it's okay. I would not agree that we're killing everything off, and so now it's just a Hoagland solution. I think there's still a lot to it, and there's certainly other things the microbes are doing in the system, such as creating growth hormones and different things that we haven't yet completely researched, and their contributions to growth in a hydroponic system. But yeah, no, I agree.
Stacy, the question is, it's a two-part question, and the second part of the question is really what's in these mixtures that you're testing, because you have biologicals in them, and you have to have a fertility source. And so when you started out with your home brew and you added the teas, you had both of that, and the pH was changing, and so in that case, did you actually get the tea tested with the lab test to see what kind of nutrients that you had in there? Because your pH kept rising, so you're exchanging anion to get OH out. The plant is giving up OH to bringing in a lot of anions in those roots that would make the pH go up in terms of the plant. But what's going on biologically, I don't know what are the components in there. And second of all, when you had the second product that you had, what's in there that's not changing the pH? Do they have a proprietary buffer that they have, or is it purely biological? I don't know.
The other products, all of the organic products fluctuated in pH, no matter what, whether the compost tea or any of those other liquid organic nutrients that I was using. Your question about analysis, yes. When I did the compost teas, I created the compost teas, and before I used them, I sent them out for a nutrient analysis, so I knew I was pretty close to the targets. And again, it kind of speaks back to Rafi's question, with the microbes doing their work, that I was seeing with that amount of compost I put in and the aeration time and so forth, I was getting a nutrient level close to what a hydroponic solution would be. That I don't know. I did not analyze for proteins and amino acids and so forth.
So we have a question online. It says, why is it necessary to mix the organic feeds to try and mimic the ppms we require in organic feeds? Is it possible that sufficiency levels are different in organic operations?
Absolutely. That's a great question. Oh, I'm sorry. So go ahead. Do you want? Okay. So the question is, why did I match the nutrient levels in an inorganic solution to an organic solution? Is it possible that you can run a different ppm of different things in an organic solution compared to inorganic? That is absolutely the case. I matched them simply to try to level the playing field as much as possible in a worst case scenario. But what we do find is in most organic systems, whether it's in one of these liquid systems or in an aquaponic system, we find we can use much lower rates of nutrients and still get the growth that you would see with a full-strength solution. Now, part of that reasoning is that your electrical conductivity meters only measure what is in ionic solution. And with organic solutions, even with the microbes doing what they do up front, they're continually decomposing things and taking in nutrients to their bodies before they die and then release it. So it fluctuates. So you might have a lot more nitrogen in your system than you're seeing on an EC meter.
I have a very small technical question. At the beginning, you talked about adjusting pH using citric acid. Have you considered using acetic acid, which is also an organic acid that's carbon-based?
I tried using some vinegar. That's vinegar, right? Yeah, I tried it, but that still wasn't strong enough either. Yeah, and that's something we could try. But I'm very interested in seeing that effect. Do we really have to push that pH down, or are the microbes able to naturally buffer that for us and make things happen the way they should?
Taking this to the very simplistic, your controls look beautiful. The idea is wonderful, and having things plug up on you is a pain in the neck.
That's right. Oh,
so
it is.
The issue here is to try and reduce your number of variables so that you get clean information with more simple steps.
Absolutely.
And things like a little cube of something which is organic material, or not too complicated organic materials that would be in the 3 other pans, and comparing that to your control, what your end point is that you want to have better looking lettuce that's actually more nutrient value lettuce. Have you given any consideration to avoiding getting so complicated as things like molasses, and sticking to something which might be just purely a combination of organic molecules?
Yeah, this was kind of a bigger picture attempt. There are so many more questions and so much more research and pulling out each of those variables. We tried to start pulling some of those variables out when we were trying to pinpoint what was causing the plugging, but it needs rigor. I mean, we need to really, there's so much work that needs to be done with this, and so I agree. It's just we were trying to kind of get a ballpark picture of what's happening and what our challenges are, and there are a lot of next steps.
What if you just boil the organic tree, make it a boil for 2 minutes, and that will help the microorganisms to turn to encapsulated or turn spores, and give them a time, just like few days or 5 days, 6 days, to recover. And then all the solution of the organic tree will be available for the many tiny roots to get.
Okay, so you said boil, right? Yes. Well, here's a very interesting part of this. We did. So we took that nutrient that was plugging up on us. I did boil it, and then I let it cool. And the interesting thing is, it still killed the roots. There's something very strange happening, and we have not been able to research enough to pinpoint what it is.
So I was just going to comment that we've done a lot of trials, especially with fish, right? And we have gotten some results like that on the roots with some fish emulsions. And we think what is happening is that we get some kind of fermentation because either the fish emulsion is too, has too many sources of sugars, and so you start producing alcohol.
Yes.
And that alcohol immediately kills the roots, right?
So that's maybe
kind of
what
I saw there. Kind of makes me think that. If you start changing the brands, like we started changing brands, and you know, there are some fish out there that are more pH, let's say, stable,
Okay.
because now the NOP is allowing to use phosphoric acid
Right.
on the organic fertilizers.
Mm-hmm.
And now you can actually buy some organic fertilizers that are more pH stable.
Mm-hmm.
And that works way better on drippers and everything.
Yeah.
Although I would say you don't need your biology to be inside your drippers.
Right.
That is not a good idea, I would say.
That's a whole other conversation. Yeah. Yeah.
Yeah. What I would say is that there's a lot of fertilizers out there that could that we can benefit from the nutrients, but people is taking advantage of the prices, and
Yes.
because they say soluble and everything.
Mm-hmm.
I think the real challenge, because although I know we might say this fertilizer works, this not, it is not commercially economical
Yes.
to use a lot of them.
Right. That's a very good point.
You know, we have found 5, 6 fertilizers that work pretty well on nitrogen, but it's not economical. It's just not.
Right.
We
So,
would not be able to pay for it. Maybe on other businesses we can pay for them, but
yes.
in our business,
and vegetable production, forget it.
so our challenge right now is more looking on natural and cheap sources and convert them. That is the big idea, right?
Right.
So let's say last summer we started doing this experiment. We were getting poultry manure. It was pelletized and disinfected for $200 a ton with 5% nitrogen. If you use your biology and you can extract these nutrients, you have cheap fertilizer. And I think that is really the future. Because this people is doing the same thing and selling it for a
Right.
very high price.
Yes.
Because they don't want you to know the secret. Right.
Right.
But I think that is a real challenge looking
Right.
for.
So that's the thing. Like I said, the focus of this was to see if we can make a liquid organic nutrient that would work just as well as the inorganic. But realistically, like you said, anytime you put the biology in the drip system, there's going to be some issues with clogging, whether it's the nature of the product itself or bioslime, just from the bacteria itself. So from what I've seen from experienced growers that are starting to do this, is it's really much easier and much more effective to put your nutrition in the media. You're not going to have quite as much control because you don't know what's becoming available as quickly as you would being able to test a liquid. But that keeps the biology in the media and not in your drip line, and can help with the cost, because these, like the Terra that we're going to be using, is very expensive. And so to even try that on tomato production, it's kind of, in a way, why even try it, because a grower's not going to be able to use it.
Is it possible to create your own organic fertilizer?
Your own organic what?
I mean, make your own recipe for the organic.
Yeah, certainly. I mean, that's kind of what I was trying to do with the compost teas. So there are ways to try to do it, to make a liquid nutrient on your own, but most of the time, other than using a compost tea and just liquid extracting stuff, you're going to have some kind of digestion process and engineer it. You know, we're not all engineers, so it's kind of difficult.
But it's very easy. It's not.
Okay, give me a recipe. I'll work with it.
Yeah, I have.
I have a question for Dr. Giacomelli. I was intrigued by your assertion that the next generation of CAA farmers have to be educated for jobs that currently do not exist. Would you describe your vision of the educational process for these future agronomists, scientists, growers?
Yeah, yeah, we have plenty of time for that. I don't know about a vision, but certainly a recognition that that's a challenge. I would always, to be able to succeed, not knowing how you're going to apply the knowledge, but we recognize that we teach fundamentals, and if you teach fundamentals, they're almost always correct into the future. Yeah, there's cold fusion that somebody's figuring out pretty soon, but not yet, I don't think either. So the laws of physics and the biological responses of organisms can be predicted and can be modeled. So learn the fundamentals about how they function and then apply them to the future opportunities. I came from a small farm that did not have greenhouses. I always thought that would be great to be able to protect from the weather. So here we are, other people had greenhouses, and now there's more and more people having greenhouses. And in the future, or at least as it's developing, these indoor multi-level farms, growing under artificial lights, it's not logical that it would be practical. Yet we see situations where it can make sense, where the environment outside is so extreme that you can't even harvest the sunlight to use for growing the crop, and you need a crop. In the future, I expect that there'll be more opportunities along those lines that we just can't envision at this point. Learn how to grow, understand how to grow, and don't give up on fundamentals. Well, I want to thank everyone for coming today. Thank you very much. We're still on, right? Okay. Stacy, thank you for your efforts and all the information and the challenges to come. I think you're going to be busy, as we all will. Yes, we have some fresh lettuce and some tomatoes that you're welcome to take and try them out. Let us know how they taste. Yes, it's late on Friday, end of the week. That comes out. There you go. Thank you very much. Have a good evening, and we'll see you in 1 month, roughly. All right. Thank you.